Hello everyone, welcome to the session to video of Generative AI Developer series, which is on what is LLM. My name is Habib and today we will understand more on LLM, that is Large Language Model. In my past videos, we learned what is Generative AI. Today we are learning LLM, which is the backbone of Generative AI application like ChatGPT. Now let's talk about the content of this video in detail. We will understand what is LLM, how LLM is related to generative AI or ChatGPT application, what are the various application areas where LLM can be used. Then we will talk about how LLM works, various challenges and future of LLM. We will also talk about backbone of LLM, which is transformer. Finally, we will learn how to create AI applications using LLM practically. If you find this content useful to you, don't forget to like, subscribe and hit the notification bell for more update. So let's get started. The word LLM comes very often when we discuss on generative AI or ChatGPT. LLM is large language model that provides capability of general purpose language understanding and generation. That means we can ask question to LLM in human speaking language. LLM understands it, process it and generate contextual response from its knowledge base. LLM uses large amount of data and billions of parameters during training of the model. LLM also provides a wide variety of natural language processing tasks like summarization, question answering, translation, and many more. GPT and BERT are the popular large language models. Large language models utilize deep learning algorithms to recognize, interpret, and generate human sounding language. GPT developed by OpenAI and is one of the most recognizable large language models. Google's BERT, Facebook's Llama, and Anthropic's Claude are other examples of LLMs. Large language models are used in content creation, translation, code generation for developers, audio transcription, and virtual chat or assistance applications. Let's understand the relationship between generative AI and LLM. In my past video on Introduction to Generative AI, I explained the relationship between AI, ML, DL and generative AI. And here we will only talk about how LLM fits in the ecosystem of artificial intelligence. Please do watch my video on Introduction to Generative AI if you haven't watched it. You will see the link in the description of this video. LLM model is one of the generative AI model with all various capabilities of NLP for language understanding and generation. You can see the diagram that shows the placement of LLM in the AI ecosystem. Most of us are using ChatGPT, which uses LLM as a backbone that generates the response to the user inputs. ChatGPT is a chatbot tool based on LLM model called GPT. Many people has confusion between GPT and ChatGPT. While they might sound similar, they are not the same. As shown in the diagram, ChatGPT is a kind of super chatbot that can generate answers in natural language on almost any topic based on input. It has been trained with an LLM called GPT, that is Generative Pre-trained Transformer, which is the large language model developed by OpenAI with billions of parameters. The extreme popularity of ChatGPT can be explained by its accessibility and the wide variety of the use cases it serves. From drug discovery to material manufacturing, ChatGPT has the potential to revolutionize many industries. But what does ChatGPT actually do? It can provide input from marketing, drafting emails, summarize the text, or even suggest lines of code. The more precise your prompt, the better the output. Hence, there is an emergence of a new discipline called prompt engineering. Alternatives to ChatGPT includes other generative AI tools like Google Gemini, Cloud A, and Microsoft Bing Chat. LLMs such as GPT and Google's BERT are part of general purpose AI. These large models can be used to perform text-based tasks like translation, sentiment analysis, and question answering. LLMs are trained on massive amount of text data and can be integrated into generative AI tools like ChatGPT or custom AI solutions for which they generally require to be fine-tuned by a team of data scientists. Some of the LLMs like Meta's Llama are open source, whereas others like GPT must be licensed. Here is a list of some of the most important areas where LLM can be used. First is text generation capability, which has the language generation ability such as writing emails, articles, stories, poetries, and many more in response to prompts that can be refined and polished. An excellent example is RAG, which is known as Retrieval Augmented Generation. Let's talk about content summarization, which summarizes long articles, news stories, research report, corporate document, and even customer history. The third point we are talking about is AI assistants. They are the chatbots that answer customer queries, perform back-end tasks, and provide detailed information in natural language as a part of integrated customer care solution. Next is code generation that assists developer in building applications, finding errors in the code, and uncover security issues in multiple programming languages like Python and Java. Language translation is one of the fundamental capability of LLM that provides wide coverage to organize various languages and geographies with fluent translations and multi-language capabilities. From this, we understand that LLMs are impacted every industry. Language translation is one of the fundamental capability of LLM that provides wide coverage to organize various languages and geographies with fluent translations and multi-language capabilities. From this, we understand that LLM has impacted every industry from finance to insurance, human resources to healthcare. By automating customers' self-service, we can accelerate response time on an increasing number of tasks as well as providing greater accuracy, enhanced routing, and intelligence context gathering. Now let's talk about how LLM works. Large language models work by analyzing vast amount of data and learning to recognize patterns with that data. The type of data that can be fed to a large language model can include books, pages pulled from various websites, newspaper articles, and other written documents that are human language based. In terms of the technicality of large language models, there are some key steps that must occur for them to work. As shown in the slide, step 1 is pre-training. Step 2 is fine-tuning, and step 3 is reinforcement learning. A large language model needs to be trained using a large data set, which can include structured or unstructured data. Once initial pre-training is completed, the LLM can be fine-tuned, which may involve labeling data points to encourage more precise recognition of different concepts and meanings. In the case of large language model, the data points are words. In the next phase, deep learning occurs as the large language model begins to make connections between words and concepts. Deep learning is a subset of artificial intelligence that is designed to mimic how the human brain processes the data with the proper training. Deep learning uses neural network that makes inference from unstructured data to analyze information to solve problems. Once the model training is completed, it should be ready to produce language-based responses using specific prompts. Model learns from feedback by using reinforcement learning once the users start using LLM.
Here we are talking about challenges with LLM. However, it is important to understand that these models are not perfect. First, we are talking about the lack of domain knowledge by LLM. The knowledge that these models possess is parametric knowledge that they are learning during training phase. These models should be able to generate good responses to the questions about general knowledge from their training data. But they are not properly answer questions which are not in their training dataset. Also, model will refuse to answer such out-of-domain questions. For example, model can be aware of transaction processing logic in general, but not specific to a particular bank. Next point, we will discuss on lack of latest updates by LLM. LLM does not know anything about events that happen post-training. This means they will not able to answer questions about current events. Models are also trained to qualify the answers that they give for such questions. Example, if you ask which country won the highest medals in Paris Olympics in 2024, GPT-3 does not have answer as GPT-3 is trained on the knowledge before 2023. Hallucination is another big challenge with LLM. LLM often do mistakes in the gray area between known and unknown information. The answer provided by LLM can be grammatically correct but factually incorrect. Suppose a user asks, "Tell me about the life of Albert Einstein." The LLM could create a detailed but entirely fictional biography of a non-existing person, though the request for the information is about the real historical figure. The next important challenge of LLM is the model training cost. LLM are capable of generating relevant responses to the questions when they are trained on the data specific domain. They are expensive to train and require vast amount of data and compute. Also, fine-tuning models require expertise and time. After understanding challenges of LLM, let's discuss the future of LLM. As research in LLMs advances, we can expect even more remarkable capabilities. Models may become more fine-tuned for specific domains and improves their performance in the fields like medicine, law, and finance. Additionally, addressing ethical concerns will be a driving force behind LLM development, ensuring that AI generated content is both reliable and responsive. In the last slide, we saw various challenges of LLM. We can overcome some of those challenges by customizing LLM RAG, that is retrieval augmented generation, which is one of the approach of solving them. Retrieval augmented generation, that is RAG, is the process of optimizing the output of a large language model as it references knowledge base outside of its training data sources before generating a response. This way, organizations have a greater control over the generated text output. RAG extends the existing powerful capabilities of LLMs to specific domains. without retraining the model. This is a cost-effective approach for improving LLM output. So, it remains relevant, accurate, and useful in various contexts. The slide shows the conceptual flow of using RAG with LLMs. When the user sends a query, RAG first extracts relevant data from domain knowledge base, and that data will be carried along with the LLM. LLM then considers the domain data which is relevant to query and use its own capabilities to generate response to the. This will make the response more contextual and specific to a particular domain. This slide will give us an overview of transformer. LLMs are built upon transformer architecture, which excels in capturing contextual information from the text. They consist of multiple layers of attention mechanisms and feed-forward networks, enabling them to process and generate text with the context awareness. Transformer model is built on top of three key concepts: positional encodings, attention, and self-attention. These models learn to predict the next word in a sentence by considering the preceding words, allowing them to produce coherent and contextually relevant text. The transformer architecture was introduced in the research paper named "Attention is All You Need," which was published in December 2017 by Google researcher. The diagram in the slide shows various layers of transformer model. I will discuss on transformers in detail in my upcoming videos. Thanks for watching this video till the end. Next video, we will see how to interact with LLM, specifically OpenAI GPT using Python. Some of you who haven't watched my earlier videos on generative AI developer series, please do watch them. You can find links in the description section of this video.